On, go.
Sedimentary Rock Lab concluded by Michael, Jason, Luciano, and then Mrs. O'Connor.
So, the process of weathering. In our words, weathering was when a landform is beaten repeatedly or eroded away by either wind, water, ice, or other natural causes. For example, when a glacier carves out a valley, it's weathering away at the rocky sides of the mountain where it was created, often leaving U-shaped craters. So, in our model, we showed that by making our glacier, so whenever it goes down, the land comes in and falls down on itself, kind of creating that valley.
Process of erosion. In our words, erosion means the movement of sediments by wind, water, ice, or other natural causes. For example, when a glacier breaks down rocks, it moves the little pebbles / sediments down the slope or mountain. So here we had all these rocks, and then we used these to show that it was kind of pushing the rocks and all the sands into the cup. And then here's our cup there.
Process of deposition. In our words, deposition means the resting place of sediments that was moved because of erosion. For example, a river delta is an example of deposition because it is a big dump of point for sediments. We show this in our model right here when you take the sediments out using sand.
So, process of compaction. In our words, compaction is when layers upon layers of sediments pile up on top of each other. The bottom layer has to bear all of the weight of the upper layers compacting it. For example, when layers of sand pile up on the ocean floor, pressure begins to smush them against each other. So in our model, we showed that by our cup, so the bottom layers are a lot stronger and bonded together kind of because of all the weight of all the top layers pushing down on it.
Process of sedimentation. In our words, sedimentation is when the layers of rock harden and become one rock. The minerals in the rock dissolve and then crystallize, holding the compacted rock in place. For example, when layers of sand are compressed by the ocean floor and the ocean slowly closes up, it can leave behind sculptures and what are made of sand fused together by pressure to form one big rock. And here we had our glacier compacting the rocks here, and so that's how we showed compaction or sedimentation.
Information you can tell about age of rocks. The law of superposition is basically saying that the most bottom sedimentary rock is the oldest and the layer on top is the youngest. A real earth example is shown right there. Since the top layer is loose, it means that it hasn't been cemented yet, but the lower layer seems like it's been cemented, so it has to be older. And we show this in our model by gluing the bottom part of our cup, and the top one is loose.
Okay, so information you can tell from fossils and rocks. Fossils form into sedimentary rocks from dead animals, leaves, shells, etc. that fall into the ground and then get slowly covered by sediment and rocks that eventually get compacted and cemented together with the living thing's dead body inside or around it. The fossil then has its body converted into rock as well from all of the different chemicals. What we can tell about the past by studying fossils and sedimentary rocks is that we can tell from the fossils in the rocks that since there are different types of fossils per layer, it could predict what the past looked like. Like, say there's seashells, there could have been a sea, or trees, maybe it could have been a swamp or a forest. In our model, we showed this so we put a couple seashells in the cup, and you may or may not be able to see one of them, but there's one right there, near the top layer, and yeah.